we're in our final bit here where we're just going to do some practice problems with the triangle angle sum theorem and the exterior angle theorem for triangles. And be patient because you might see it one way and someone else might see it another way. Neither one is wrong as long as you get the same what? Answer, and you do it mathematically correct. All right? So the very first one is I'm looking for this exterior angle of the triangle. Notice I said exterior. It's right next to my remote interior. They're a linear pair. But if we remember our exterior angle theorem for triangles, okay, we know the two remote add up to the exterior. So all you'd have to say here is x is 65 plus 60 degrees. And that's going to be 125 degrees. That's all you have to do for this first one. Or, okay, now we're going to do the big or here on this. Or you start marking up what you do know. Okay, you do know that these two are 125 degrees, which leaves this one to be 55 degrees. Okay, and then you can use the fact that they're a linear pair that adds up to 180 degrees. So I can literally go 180 minus 55 gives 125 degrees. Do I still get the same answer? Yes. Is that just a different way of doing it? Yes. Do which one works best for you. And that's my biggest thing I'm going to keep emphasizing. Do the one that works best for you. Now, I'm actually going to work on number 7 here. And hopefully I remember I zoomed in here so you can see the work and not mess up my diagram. But here's the thing. If you're in doubt, mark up what you know. Okay? So like for instance on number 7, I am looking for x, y, and z. And here's a hint in math. It doesn't matter which one you do first. Do the one that you know how to calculate first. And seriously, the one that's easiest to do, it's really up to you. I like starting with y first. And the reason why I like starting with y is because if I ignore this line right here, I realize y is an exterior angle for the triangle on the left. Okay? Because remember, we have 1, 2, and then the large triangle. So when I do that, I say, oh, look, here's my exterior. Here's my 2 remote interior. So I'm going to do y over here in the margin. Okay? So I get the fact that y is the sum of the 2 remote interior angles. So 55 plus 90 is 145 degrees. And in fact, if you want to put that down there, it actually might be helpful later. All right? So we know y is 145 degrees. Now, if I know y, I can quickly solve for x. All right? The reason why I can solve for x is that they're a linear pair. So I can go over here for x, and I'm just going to do that one in red. X is going to equal just 180 minus 145, which is 35 degrees. So now I know the measure of that angle. However, now I'm looking for z. Well, z, the cool thing is I can use the small triangle here for z, and I can use the triangle angle sum theorem. I can add the 3 angles together to equal 180. So I'm going to go z, all right, plus 145 degrees plus 10 is equal to 180. So z plus 155, because I combine my like terms, I subtract it over, z is 25 degrees. So it kind of works out pretty cool there, and that's a horrible degree symbol, so use your imagination to help you. Hopefully that was a little bit easier for some of you to see. Now, we're going to skip over to number 9 because 8 and 9 are very similar. One's just kind of flipped over. We need to make sure that we understand this one. My daughter's crying outside the door. Hopefully she's okay. All right, so now let's look at this one. Again, you decide how you want to do this. There's 2 different approaches. Let's say you didn't see the fact that V was an exterior angle and 56 and 62 are the 2 remote interior angles. How about if I just wanted to solve for T first? Well, if I'm going to solve for T first, can I use the fact that I know the sum of the angles of a triangle add up to 180 degrees? Yeah. So I'm going to go over here and go, all right, T plus 62 plus 56 is 180 degrees. So T plus 118 degrees is 180. Subtract it, T is going to be 62 degrees. And I'm going to put it in the diagram because marking up my diagram is going to give me that visual I need all the time. Now, look at this. I have a linear pair. The linear pair, they add up to 180 degrees. So I can go V plus 62 is 180. Subtract 62. V is going to equal, here, 118 degrees. Now remember, what's 56 plus 62? 118. Remember, these two can add up to the exterior. And then last but not least, we're going to solve, oops, let me put the 118 here in the diagram. I can solve for what's missing, okay? I'm going to go in green here and use the fact that those three angles add up to 180 degrees. So I can go W plus 118 plus 25 equals 180. Well, 118 plus 25 is 143. Equals 180. Subtract 1, and we just used basically a linear pair and the angle sum theorem for triangles. So not too bad. Now, just for time-wise, we're going to try a few of these, and the ones that I want to emphasize with you that I think would be really good to see and not to forget to do would be 11 and actually 12 here. Now, on number 11, we have here the two remote interior and the exterior, okay? But I'm missing one of my remote interior. But if I remember the rule, I know the measure of angle 2 plus 32 degrees is equal to 120. And then I subtract the 32 over, and I get 88 degrees. And that's just using my triangle exterior angle theorem. But some of us don't see that quickly. But we do see the fact that this is a linear pair. So this is one way of doing it, and you get the same answer. Now, on the next one, I don't want you to make this difficult for you because this is actually really easy. But don't forget to look for exterior vertical angles, because if I realize I have vertical angles, you would realize that 3 and 4 are exactly the same size. They don't change. So if I know 3, I automatically know which one? 4. So I'm going to use the fact that these three angles add up to 180. So the measure of angle 3 plus 72 plus 86 equals 180. All right, so we're going to zoom in a little bit more on there. And then I know the measure of angle 3 plus, and this would end up being 158 equals 180. So the measure of angle 3 is going to be 22 degrees. All right, so 22 degrees. I can't write it today. So this one then is also 22 degrees. Now I know 2 out of the 3 angles on this side. So now I'm looking just for 5 because I know the measure of angle 4 is 22 because of the vertical angle theorem. So I go 22 plus 70 plus the measure of angle 5 equals, boy, I'm running out of room here, equals 180. So that's going to be 92 plus the measure of angle 5 equals 180. Subtract 92, the measure of angle 5 is going to be 88 degrees. So it works out pretty good. Now, the last but not least, we're going to ask you to classify triangles. Now, you classify based on the information they give you. If they only talk about sides, you can only use sides to classify it. If they only talk about angles, you can only use angles to classify it. And if they talk about both, use both. So in the first one, they talk about the sides. Well, when you talk about sides, that's equilateral isosceles, okay, or scalene. Those are your only 3 choices. So on here, it says the sides of a triangle, and so I just draw this real quick, are going to be 10, 8, and 10. Well, that means these 2 are congruent to each other. Well, if a triangle has at least 2 congruent sides, it's what? Isosceles. And this is a fun word. Some reason it's difficult to spell, but it works out pretty well. Now the next one, they talk about the angles. Now look at the measures of the angles. We have 44 degrees, 110, and 26 degrees. Right away, I'm only talking about the angles, which means we have equiangular, we have acute, we have right, and we also have our obtuse. Well, I have an obtuse angle. So therefore, we have an obtuse triangle. Not too bad. All right, I hope this helps. Guys, make sure you study definitions. Like, I'm going to ask you to know all the definitions of the different types of